All right, welcome to lesson 5 from polynomials. We're going to be getting away from graphing and getting back into the algebra that we can do with polynomials. And today is going to be looking at how to divide polynomials by each other using two different methods. We're going to be looking at long division, and we're going to look at something new called synthetic division. And what they're useful in are in how to factor polynomials. So taking a look at long division, we're going to refresh our memory on long division. Now we're going to do using numbers. Okay, so if I want to take 374 and divide it by 3, you might remember from elementary school, you would take the 3 on the outside of your division box, and you would say 374 inside the box. And here's what you would do. You'd say, okay, how many times does 3 go into 300? Or really, you always ask, how many times does 3 go into 3? 3 goes into 3 one time, and then you did 3 times 1 and got 3, and you subtracted straight down. When you subtract, you get 3 minus 3, which is 0, and you bring down the next number. Actually, you bring down all the numbers. Then you ask, how many times does 3 go into 7? 3 goes into 7 twice. 3 times 2 is 6. You do subtraction. 7 minus 6 is 1. Bring down the 4. How many times does 3 go into 14? It goes in there 4 times. 4 times 3 is 12. Subtract to get 2, and we would say that this fraction, or 374 divided by 3, is 124 with a remainder of 2. The other way we would say this a couple different ways. We would say 374 divided by 3 is equal to 124 R2, but we don't actually use R2 when we're dealing with fractions. That remainder of 2 is the leftover out of the original fraction. So it's actually 124 and 2/3. What I'm going to remind you here, because I'm going to be looking at this kind of idea later on, is that 124 and 2/3 is really 124 plus the remainder over the original bottom. Okay, so plus 2/3. So you got to make sure you remember that idea. So what I really want to point out here in this particular thing is, what was the process that we did? It's a very repetitive process, and the process really is, how many times does something go into the first part? So how many times does 3 go into 3? Okay, then we said, oh, it was 1, so we said, let's multiply and subtract. Well, once we subtracted, then we asked the same thing. How many times does blank go into the next part? So in this case, it was, how many times does 3 go into the next part, or the 7? And then we multiplied and subtracted. Notice it's a very repetitive process that we do over and over and over again until we get to the very final piece. And that piece is either 0 or it's not. If it's not 0, then it's a remainder. If it is 0, then it's a factor. So we know that 3 is not a factor of 374 because there is a remainder. So what we're going to start with is long division of polynomials. The process is exactly the same. All right, so let's go ahead and move forward into that idea. Long division of polynomials. So as I mentioned, it's exactly the same process. We're going to divide x squared plus 3x minus 12 by x minus 3. So same idea, slightly different look, I guess. We're going to say it's x minus 3 because that's the thing we are dividing by. Goes outside the box. And then in this case, x squared plus 3x minus 12. Now, we actually don't, when we're looking at how many times does something go into something, we actually don't look at the 3 here. We actually ask, what can I multiply by x to get x squared? And we know that x times x will get me x squared. So we have to do this multiplication now. And don't forget to distribute. This is x times the entire thing in front. So x times x is x squared, and x times minus 3 is minus 3x. We subtract. So x squared minus x squared is 0. 3x minus negative 3x is 6x. And then we drop the last piece. So notice so far the process is the same. How many times does x go into x squared? It goes in there x times. We multiplied, and then we subtract. So the next step is to do the same thing. How many times does x go into 6x? Well, it goes in there 6 times. If we took plus 6 and multiplied by x minus 3, we get 6x, and we get minus 18. We're going to subtract. 6x minus 6x is 0. Negative 12 minus a negative 18 is positive 6, which means we get a remainder of 6. So if we were to write this as the same idea that we did a minute ago, as a division, or a fraction, I mean, over x minus 3. When I divide that quadratic by that linear piece, I get the top thing, which was x plus 6, plus my remainder over my factor. That is our final answer. Let's try another one here. We're going to do x minus 4, so x minus 4 goes on the outside. And x squared minus 3x plus 1 goes on the inside. And we're going to ask the same idea. How many times does x go into x squared? It goes in there x times, because x times x gets x squared. So if I multiply those two things together, I get x times x, which is x squared. And I get a minus 4x when I multiplied by minus 4 and x. I subtract. Sorry about the bell. X squared minus x squared is 0. Negative 3x minus a negative 4x is a positive 1x. And I bring down the plus 1. Then I go into step 2. I say, how many times does x go into x? It goes in there 1 time, which I just multiply this by 1, so I get x minus 4. And I'm going to subtract. X minus x is 0, and 1 minus a negative 4 is a 5. So our answer is this number divided by, or this polynomial divided by this polynomial is x plus 1 plus the remainder over x minus 4. And there we have it. That's our final answer for that one. All right, we can actually do any type of polynomial, whether it be quadratic divided by linear, or cubic divided by linear, or quartic divided by quadratic. The process is still the same. So a lot of the question comes down to why. Well, one of the things that we do with polynomials is to determine if a polynomial is a factor of another, meaning can I multiply two polynomials together to get this other one? If the remainder is 0, then yes, it is a factor. And if the remainder is anything else, then the answer is no, it's not a factor. So this is a way the question could be asked. Is x plus 4 a factor of x squared plus 6x plus 7? Now we could do that pretty quickly, hopefully, once you guys get the hang of this. This becomes x plus 4 on the outside. and x squared plus 6x plus 7. What times x gets me x squared? I know that to be an x. X times x is x squared, and x times 4 is 4x. Going to subtract. X squared minus x squared is 0. 6x minus 4x is 2x plus 7. And how many times does x go into 2x? It goes in there twice. X times 2x is 2x. Sorry, x times 2 is 2x. And x times 4 is 8. Subtract. We get 0 there, and 7 minus 8 is negative 1. So the question was, is it a factor? But since our remainder is negative 1, the answer is a very big no, because the remainder is not 0. Oops. All right, this is the last one before we move on to synthetic division. So we're going to divide a quartic by a quadratic, but the process is still the same. So here we're going to say x squared plus 3x. That's interesting. Thanks for that. All right, plus 3x minus 1 goes on the outside. And on the inside is this lovely quartic function that obviously takes a little bit of time to write. (12x squared minus x minus 1. And we do the same thing. What can I multiply by x squared to get x to the fourth? We know that to be x squared. And if I multiply x squared by the polynomial in front, I get x to the fourth. X squared times 3x is plus 3x cubed. Notice that the like terms are being put in the same columns here. X squared times minus 1 is a minus x squared. And when I subtract, x to the fourth goes away. 7x cubed minus 3x cubed is a 4x cubed. 12 minus negative 1, which makes a plus 13x squared. And we drop the leftovers. Next part, x squared times what gets me 4x cubed? That's going to be a plus 4x. 4x times x squared is 4x cubed. 4x times 3x is a 12x. And 4x times negative 4 is a, 4x times negative 1 is negative 4x. And again, we are going to subtract. Those go away. 13 minus 12 is 1. Negative x minus a negative 4x is plus 3x. And I drop a 1. And you notice we get x squared plus 3x minus 1. How many times does x squared go to x squared? It goes in there once. So I get x squared. 1 times 3x is 3x. 1 times negative 1 is negative 1. And I get a 0. That means the answer to this one is a big resounding, if I can get the pen to write here, yes. All right, let's take a look at what our next idea is. Our next idea here is something called synthetic division. It's actually a simplified method to divide by a linear factor. Now, I try to write this out in words on how to do this. It gets a little bit bogged down, but it's actually a very simple process. Please note, it only works with linear factors. So when you divide by a linear polynomial, You can do synthetic division, but that's the only time you're allowed to do synthetic division. This method uses multiplication and addition. And we're going to do this problem right here, and I'm going to try to explain using my words, but I'm going to show you what that means as we go. So notice we are dividing by x plus 1. That is a linear factor, and therefore we can do synthetic division. So here's what synthetic division looks like every single time. You're given, or you get to put a box here and a line here. Inside the box is the 0, or what makes that factor 0, or the opposite of the number on the inside. So -1 goes inside the box in this particular case because we're dividing by x plus 1. The coefficients of the original big one goes in across the top line. So the coefficients are 3, there 3, let's see if we can get this cleared up here. 3, -4, 2, and -1. All right, now here comes the rest of the process. Remember I said this has to do with multiplication and addition. So first things first is bring down the 3. I'm going to get 3 steps here. Bring down the 3, the first number. Multiply that number by the number in the box. That product goes underneath the 4, and then we're going to add the 2 numbers. All right, so let's see what that means. We're going to, not sure what's going on there with my pen. All right, let's try this again. We're going to drop down the 3. We're going to say -1 times 3 is -3. Okay, so we're going to drop the 3. We're going to multiply the box by the number in the bottom of the line. We're going to take it right below the -4, and then we're going to add those 2 numbers. When I add those 2 numbers, I get a -7. That sum goes down there where I put the -7, and you repeat the process until you get to the very end. And the very end for us is going to be a little box right down here. The number in the box is your remainder. We'll get to that in a moment. All right. Complete the process. All right, -1 times -7 is a +7. If I add those 2 things together, I get 9. -1 times 9 is -9. And if I add those 2 things together, I get -10. So when I do this division, this cubic divided by this linear function is this answer. But we need to make sense of this answer. If the last number in the box is your remainder, the first number to the left is your constant. The next number is your linear, which means x to the first power. Your next number would be your quadratic, which would be x to the second. If you had another number, this would be your cubic. Now what I mean by that, it's actually your coefficients. So my answer here would be 3x squared minus 7x plus 9 with a remainder of -10 divided by that x plus 1, the original piece. Now, I understand if this is confusing because you've never seen this before, but by practicing, this actually is faster than the long division. So here we're going to do synthetic division on a couple of problems here. So the -1 goes in the box because that's the 0 of this piece here. Then we put the leading coefficients, or sorry, all the coefficients across the front, or across the top. Coefficients of 1, 4, 1, and -6. We draw a line to do our sum, and then I always put a box down here for my remainder. That's the setup. We're going to drop the 1. We're going to multiply by -1 and get a -1. Then we're going to add, and we get a +3. Then we go -1 times 3 gets a -3. We add them together, and we get a -6. -6 is wrong. I don't know where that came from. 1 plus -3 is -2. Then we're going to say -2 times -1 is a +2, so we get a remainder of -4. So that means the answer to this problem, the first number, because I have 3 of them, is the coefficient to a quadratic. So it's 1x squared plus 3x minus 2 plus -4 over x plus 1. And that is the process for that. We have one more example like this. This one gets a little double star here because it has something missing that you have to pay attention to. When I plug the box in, the box here is a -4. When I do the coefficients, you have to include the missing values as well. Notice x cubed minus 13x plus 12 is missing an x squared because technically there's a plus 0x squared up here. And I have to include that coefficient. So I get a 1 and a 0 for my x squared, a -13 for my x, and a 12. So this is very important that you get that 0 or you will get the wrong answer. All right, process, drop the 1. Multiply by -4, we get -4. We add those two things together, we get a -4. -4 times -4 is +16, and when we add those two things together, we get a +3. I forgot to put my box down here. All right, -4 times 3 is a -12, and finally we get one where the remainder is 0. That means my final answer is just the polynomial, which means x plus 4 is a factor of this cubic, and its other factor is x squared, because there's only one, minus 4x plus 3 with no remainder, so that's our final answer. All right, we have one more idea before we call this video quits, and that's something called the remainder theorem. It's actually a pretty handy theorem if you're trying to do what this is, let's say what this is going to ask. So if you're given f of x is equal to this big cubic function or any other type of function, and you want to determine what is f of 3. Well, f of 3 means take a 3 and plug it in for all of the x's and hope that you don't make any calculation errors. But what the remainder theorem says is that f of 3 is equal to the remainder when f of x is divided by x minus 3. So we can use synthetic division to evaluate f of 3 very quickly. Now, let me point out what I mentioned there in the beginning. F of 3 would mean, hey, let's take 3 and go 3 cubed plus 2 times 3 squared plus 5 times 3 minus 1. Now, yeah, you'd have to go to your calculator and you have to do that, but synthetic division, usually doesn't need a calculator. So x minus 3 means I put a positive 3 in the box. I use my coefficients, which are 3, 2, 5, and negative 1. I draw my line and draw my box for my remainder because the remainder is the one that I want for f of 3. All right, so I go 3, drop 3, multiply by 3 gets me 9, add 9 and 2, I get 11, multiply by 3, I get 33, add 5, I get 38, multiply by 3, I get 90 and 24, which is 114. And 114 minus 1 is 113. Therefore, f of 3 is equal to 113, and done. Notice we did not have to do any substitution. All we did is some quick synthetic division. And we got our answer. And if we wanted to do one more really quick to make sure we understand this, we want to use, this is actually how the wording is going to be in your textbook. Use the remainder theorem to find p of negative 4 for this thing, p of x. So if you're doing p of negative 4, that means a negative 4 goes into your box. And your coefficients. Notice that I'm missing a cubic. So I have an x to the 4th, and I need a 0 for my x to the 3rd. I get a negative 5 for the square, a 4 for the linear, and a 12 for the constant. Gonna do this, draw my box, because that is what I want. And the process continues. We're gonna drop the 1, multiply by negative 4, and add. Multiply by negative 4, which is 16, and add. Multiply by negative 4, which is negative 44. Oh no, these numbers are getting big. Add, we get negative 40. Oh, negative 40 times negative 4 is 160. And if we add those things together, we get 172 as our answer. So that means this is equal to 172. And there we go. That's our final answer. All right, so remember what we've done today. We have done synthetic division, we've done long division, and we've done the remainder theorem, but it's all about division. All right, so I'm going to leave you with this, and I hope you learned some stuff today, and I hope you can use it tomorrow and in the future. I will see you guys tomorrow.